Good day. You should now have watched all of the demos. You should have made diagrams of what things look like before and after. And those diagrams are to help you remember what you saw and also help you remember how to classify things as chemical or physical changes. We start off with a paint can lab burner. And here's the equation you copy out. CH4, that's methane, the main gas in natural gas, plus two O2s, also gas, little g, becomes CO2 gas plus two H2Os and water. And so this water is in the form of a gas, not a liquid. Now here the carbon was latched onto hydrogen. Here it's latched onto the oxygen. So right away we know that's a chemical change from the formulas. But we also know we produced heat, we had a flame, we had a color change, all those good things. So the paint can lab burner is definitely a chemical change. Next one we have is sugar plus water. So this is the kind of sugar you buy at a store. There are all kinds of different types of sugars, but this one was sucrose. And sucrose is C12H22O11 and then a little s for solid in brackets. Make sure you're writing the symbols, the letters up high or capital, and the subscripts get written down lower to the right. When we finish, we get C12H22O11, but now it's aqueous. It's mixed with water. The formula has stayed the same, and so that's pretty good evidence that sugar and water mixing is a physical change. In fact, it's dissolving, which we know is physical change. Not all the sugar dissolved, we had simply too much, but a lot of it will have disappeared into the water. The next one was in the fume hood, and that's where we had the sugar and the sulfuric acid. So the sugar is going to be the same. It has our most exotic chemical equation. You may have to pause it to get everything copied. So here's the formula of sugar, same as before, C12H22O11, solid, plus 11 H2SO4s, that's aqueous, becomes 12 C's plus 11 H2SO4 dot H2O gas. Nasty, nasty stuff. That's why we did in the fume hood. Fairly unpleasant to breathe. You may have noticed that all of a sudden we got a very black material, and that was the carbon. Essentially, the sulfuric acid was pulling the carbon out of the sugar. So that clearly, with the heat we produced, the color changes from white to yellow to brown to black, all those things illustrate a chemical change. Now we have KMNO4 plus glycerin. So this was done in the fume hood, and our lab assistant did a great job of getting a nice little volcano-shaped cone made out of the KMNO4, and then pouring a small beaker of glycerin on top. Well, KMNO4 is the purple stuff, and we've used that stuff before in their KMT unit. Glycerin is that slimy stuff that we've used before when we were having you put glass tubing into rubber stoppers. And it's a very important biological chemical related to fats. We make the 14 MnO2s, we make the 14 KOHs, the 9 CO2s, and the 5 H2O. And you can see we had so much going on, I didn't worry about the states. We saw that fire was produced. We had a change in our materials. We had a black crud with green streaks in at the end. All those things suggest a chemical change. Next one was burning magnesium. And burning magnesium, here's our equation. Anytime we're burning something, we're thinking of reacting with oxygen O2 gas, so 2Mg solid becomes 2MgO solid. And we see the word burning, so I should have written down right here, and I'll do that right now. I should have written that it is definitely a chemical change. So there's our chemical change. And the magnesium was by itself. Now it's combined with the oxygen, so the elements are rearranged, but we have lots of evidence for chemical change. We had this white powder that we put in to the test tube, and we heated it very carefully. And the KCl3 started solid, We end up KClS3, and that's a little L for liquid. And that's a change of state. We know change of state are physical changes. Now, once it's all liquid, that's when I could add the wooden splints. And the equation I'm going to give you is just for the KClO3 generating the oxygen. In fact, I'm not really worrying so much about the burning. So first the oxygen gets supplied, and then the wood actually catches on fire. Here's our equation. So there's the 2KCl3 liquid. See, because I'd melted it, became 2KCl solid, and the oxygen. And this is an oxidizing agent, produced oxygen in this case, which supported the burning of the wood. We had a pink flame. We end up with a white powder at the end, and it is a chemical change. A lot going on. So make sure those notes are filled in. Make sure you understand that the equations give you clues about chemical and physical changes, and your observations do as well.